This is ASFurther Maths. We're in Unit 2 matrices and we're looking at transformation matrices. So up until now we've been transferring different points by way of a matrix. So we put the point, for example, 2, 3 into this and work out where it comes out. We're now going to take a wee look at what happens to lines under different transformations. So straight lines stay as straight lines unless the determinant of the transformation matrix is 0. To perform a transformation to a line, find a general point in the line, multiply it by the matrix and turn it back into Cartesian form. Cartesian forms, of course, in terms of x and y's. So if we find a general point here for this, and it's a matrix 4 minus 1, 2, 5. This is a bit of a tricky concept to get your head around, but if I take a random point t, that's the x coordinate. What's the y coordinate going to be? How do you get the y coordinate if you have the x coordinate? You times it by 7. So it'll be 7t. If we multiply this out, 4t minus 7t, so that'll be minus 3t, and then 2t plus 35t, so we get 37t. So if we put anything from the line y equals 7x in, we get out things of the form of this, where x is minus 3t, or if you want t is x over minus 3, or y is 37t, so y is 37. So what am I doing? Change my t here for an x over 3. Minus there. So y is minus 37x over 3. Or if you want, 3y is minus 37x. And the points that were on the line y equals 7x are being transformed, and they'll all then land on this line here. So quite an awkward wee kind of gradient there, but hopefully you get the idea. So this is a silly idea to try and draw this, but y equals 7x is a reasonably steep line going up like that. And then y is minus 37 over 3. So what's a gradient of kind of minus 12-ish? And going through the origin, and they all kind of land on there. And that's a cool. You have another method of doing it if you want, which it makes a lot more sense, I would think, but it's to pick two random points that we know lie on this line. So what then points do we know lie on the line y equals 7x? So pick 2 points in the original line. So 4 minus 1, 2, 5 was our matrix. I know the point 1, 7 lies in the line. As we send that through, we get minus 3, 37. I also know that the point 2, 14 lies on the line. 4 minus 1, 2, 5, and that gives me minus 6, 74. What we've just given ourselves is 2 coordinates on the new line. So if we were to plot, you don't even need to plot them, but you can use them to work out your gradient, and just find the equation of the line through minus 37 and minus 674 from your GCSE maths, and that would make it work out. Determinants and transformations then. So the determinant of a linear transformation represents the change in area from the object to the image. A determinant of 0 means the area is 0. So what does all that mean? Let's get the points 1, 1, 2, 1, 2, 2. I'm going to go for the known ruler approach here. Hopefully you'll forgive me. There's the point 1, there's the point 2, 1, and there's the point 2, 2. And this is our triangle. That's A, B, and C, and find its area. So the area of this triangle, the base is 1, the height is 1, so the area of that triangle then is a half. Transform each point by the matrix 1, minus 1, 3, 1, and sketch its area. So let's transform each of these points. So it's 1, minus 1, 3, 1. You of course could set up the 3 coordinates like that. For some reason I always like doing it just separately. The point 1, 1 goes to 0, 4, 1, minus 1, 3, 1. The point 2, 1 goes to 2, minus 1, which is 1. 7. 0.22 goes to 2 minus 2, so it's a 0, and then 8. And if we then plot this on a graph, goodness, let's see what we have. So we have 0, 4 and 0, 8. We need to go a wee bit higher here. And then 1, 7, 0, 4 and 0, 8, and 1 across and 7 up. So we end up then with something like that. How could you work out the area of this shape? That distance there is 4, the perpendicular height's 1, so the area of the new shape is going to be 2. But the point that they're making is that you can find the area of the new shape by finding the determinant, because the determinant gives you the scale factor. So the determinant of my matrix M, we go back up here, determinant is AD minus BC. A times D gives me 1 minus minus 3, which is 4. That's the scale factor of the areas. The area of this one was a half, times that by 4, and I get 2, which is the area then of this one. Transform the triangle ABC by the matrix 1, 2, 2, 4, and sketch the results. So something weird happens here. Look at the determinant of this one. 1 times 4, take away 2 times 2, so it's going to be 0. So how are we going to get the triangle of area 0? Let's see how we get on. So we are taking our points 1, 2, 2, 4, 1, 2, 2, 4, 1, 2, 2, 4. And my 3 points are 1, 1, 2, 1, and 2, 2. They come out to be 3, 6. We might not work this out. 2 plus 2 is 4, and 8, and 6, and 12. And if I plot these, see what happens. 0.36, the 0.48, and the 0.612. It all actually collapses onto a straight line because the determinant 0. The determinant 0 here, so what are we gonna, how would we get a scale factor then of 0? So times in this a half by our 0, then our new point then is going to that, because the determinant of n equals 0, therefore the shape collapses then onto the line.